Minerals are definitely the more interesting of the parts of a star because you can study them. The rocks and minerals are beautiful, like gems and stones and everything in between. Alright, the general definition of a mineral: it's naturally occurring, two, it's stable at room temperature, number three, it's represented by a chemical formula. That's a human construct. If a mineral is new, it doesn't have the chemical formula, it's probably still a mineral. 4, usually abiogenic. Now, I have some beef with people that believe that oil and natural gas are a result of plants decomposing because they are found many thousands of feet below the surface of the earth. There are no plants and animals down there. So there's a huge problem with that. Anyways, abiogenic. This means no life involved. And number 5, has ordered atomic arrangement. There you go, minerals. Now, if you take a whole bunch of different minerals together, you can form rocks. So in other words, a mineral is one crystalline structure. A rock can be 2 plus, or maybe 1. But it depends. It depends on the situation. But usually rocks are composites of many different minerals. And a mineral is its own crystalline structure by itself. Now I'm going over this really, really basically because astronomers and astrophysicists, they don't realize they're standing on an astronomical object. It's an ancient star. So here is their definition of mineral, approved by the IMA in 1995. A mineral is an element or chemical compound that is normally crystalline and has been formed as a result of geological processes. Now, there's the key word: geological processes. Geologists and, well, astronomers and every single scientist on the earth has geo, meaning earth only, okay? It's just the way they classify things. Now, it formed from earth processes is what they're saying. But, as everybody knows, earth, remember that Hertzsprung-Russell diagram thing again? Right, your magnitude going up in your spectrum, going cooler. You know, you had your O-type stars over here and M-type over here. And then you had, you know, your blue giants cruising down to where they don't have a spectrum anymore. And then they become the gas giants, which are right here, and then the rocky worlds down here. That's what we're referring to right there. Since all of us, all of my audience knows that the star cools and dies and forms the rocky ball in its center, the definition of a mineral should be as follows. a normally crystalline structure which has formed as a byproduct of stellar evolution. All my audience knows, it's been well known for me for about 3.5 years now, that stars become those little rocky balls that we call planets. So, in other words, all minerals were formed as a byproduct of stellar evolution, meaning all rocks were formed as a byproduct of stellar evolution, meaning all life itself, well, that's for a later talk, is formed as a byproduct of stellar evolution. It's inseparable. A little bit more here. Yeah, you have liquid crystals and things like that in crystal habit. Now, I would go over the crystal families. You have isometric, tetragonal, you have orthorhombic, you have hexagonal, you have monoclinic, and you have triclinic. Now, the way the minerals grow is in one of these specific orientations. Sometimes you can mix them, but this is for a later talk, because that is definitely really, really advanced, and I need to overview this stuff a little bit more. All right, today is April 11th, 2015.